let's take a look at how orbits work in space. Now this is going to cover all orbits, whether it is a planet around a star or whether it is a moon around a planet. Let's start with this little animation that I came across because it really shows it well. Here's an animation of a planet revolving around a star in this case. Now, sit back and notice the speed differences, and this shows it pretty well. Notice it's slowest out here, and it's fastest right there. So it's fastest when it's closest to the star in this case, and it's slowest when it's furthest away. That is essential. Okay, that animation is really good. It really shows the motion at different speeds. But let's sort of review that here. So here we have a planet, and I'm sure you probably drew these ellipses in class. That's important to know how to do. One focus, another focus. The planet in this case is a moon revolving around a planet. The planet is here, and the moon revolves around it. Now, let's review a little bit. So first, orbits are not perfect circles. They're always ellipses. Sometimes they are really very, very close to a perfect circle, but they're not perfect circles. They are elliptical in shape. That's important. And what you have in this general area, if this is the planet, when the moon is here, this is the highest gravitational force because they're closer. Gravity is affected by how close things are. The closer these two objects are, the more gravitational force between them, further away the less. So this area here is where there's the lowest gravitational force between the moon when it's here and the planet. And what that causes is fastest orbital velocity is in this area, as we saw in the animation, and it's slowest out here. That is important to know. Make sure you understand that and know it. Hey, Mr. Gazda here. I hope you're liking this review so far. For more review videos, click the link in the description. Okay, while we're on the orbits, I have this diagram here, and what this shows is the inner 4 planets, Mars, Mercury, Venus, Earth. They're called the terrestrial planets, okay? And then the outer planets, Jupiter, Saturn, Uranus, Neptune, which is not in here, they are called the Jovian planets, okay? Those names are important. You have to just know them. They're not in the reference table. But as long as they often get referred to terrestrial planets and Jovian, know that, because pretty much whenever questions like that come up, you then have to go here on the reference table, and it's really looking them up, comparing their densities or their size or a lot of information here. Just knowing how to use this chart is really important, but knowing the terrestrial, the inner 4 planets, and Jovian, or the outer 4 planets, is very important. And for instance, this is one question. The terrestrial planets differ from the Jovian planets because the terrestrial planets are more dense and smaller, and the way that you would know that or figure that out, you have to look it up here. You'd have to use this chart and compare, really look at the choices. But important to know those terms and know how to use this, page 15 of the reference table.